everybody. Welcome back to your Full Crew podcast. I'm Dawn Zolda, your host today, and the CEO of P3 Tech Consulting. We're in the month of August, and we've dedicated this show to the theme of maritime. We've got some amazing experts with us today who are going to talk about that. And I've got to address the elephant in the room. We're having some issues getting Sean Pribyl from Holland and Knight into the show. And Dr. Jessica Moro is literally on a ship as we speak. So she's having connectivity issues. So this is what happens when you're global and doing this thing live. But we are so thankful to have us today with us. Erdem, he is with Speeder Systems. Now, Erdem is from the Netherlands, but he's coming to us live from Turkey. And Anurag is with Seahorse Air, and he's from India, works out of the UK, but is currently in Dubai. So again, this is global, this is live. We are super excited to have both of you on the show. Before we get to our guest introductions, what I want to do super quick is thank our sponsors for making this show possible. Our sponsors today are Airspace Link, True Weather Solutions, UAS Strategic, and Clarify Consulting. So, all right, let's go ahead and go around the room. Erdem, let's go ahead and start with you. And if you could just give them your 30-second elevator pitch bio, that would be wonderful.
Hello, everyone. My name is Erdem. Erdem Kazakli. I'm from Speeder Systems. I'm the co-founder and CEO of Speeder Systems. We are developing an unmanned vessel that can operate in ground effect, out of ground effect, and also land like a helicopter. And we are doing this out of the Netherlands and the UK. We have been working with companies like Shell, Mitsubishi to deliver this technology to the world. And thanks a lot, Dawn, for this podcast today.
Well, I'm so excited. And by the way, everybody, I met Erdem's and his team actually at CES in Las Vegas all the way back in January. Bumped into him in Amsterdam at Amsterdam Drone Week. And so it's so great to finally have you on the show. I've been following what you do, and the vehicle is so cool that they've made. And I just thought, wow, he would be great to have on the show. All right, Anurag, please give everybody a little bit about your background. Oh, you are muted, my friend. You are muted.
Sorry.
There you go.
Yes. So I run a company called Seahorse Air out of UK, and we are designing and prototyping a very tiny micro seaplane, which is a trifibian craft that will work on land, air, and water. It carries 5 people and has a total lift weight of about 2 tons, a little under 2 tons. And right now trying to set up something in Maldives with the government there, and that involves a lot of policy intervention to make something like this possible there. And that's probably the best place in the world to attempt something like this.
So these gentlemen are both making very different craft. In fact, I met Anurag. I met him at Amsterdam Drone Week with his team, and I saw the little prototype of this vehicle. And we just started talking from there, and so glad to have you on the show. And we're going to have a really cool article talking a little bit about this craft. All right, so let's go ahead and roll Article 1, which is Erdem. I believe you selected this particular article. It is out of our media partner, Drone Life. So tell us a little bit about what this article says and why you picked it.
This article is about one of the first use cases of drones at wind farms. Recently, Ørsted tested a big drone, 2.6 meter wingspan drone, to deliver packages out of ships over to the wind farms. The thing is, normally you do this operation with cranes, and sea cranes are very expensive, very slow, and very hard to operate in different conditions. And drones make life easier in this operation, especially with cargo operations. One of the things that sticks out in this article is that they are making the operation 10 to 15 times faster. which also gives you a lot of flexibility in the operation. And with just one drone, they delivered, I think, around 94 boxes, and in total cargo of more than a ton over those wind farms, which would have been done by sea cranes over weeks probably. And this is the first use case, and this shows us, first of all, the drones' capability to deliver things and the reliability, efficiency, and sustainability that they bring along the way.
You know, I think when we consider the maritime environment, right, you have to consider what you're talking about, Erdem, is over the water. Of course, we're going to be talking about on the water. There's underwater applications. And you know what I never really thought about was this idea of delivering cargo to a wind farm. Can you explain, if you know, Erdem, a little bit more about wind farms? Because I just assumed it was like the wind turbine that's, you know, the energy application in the water. I guess they have platforms and people working on them, almost like an oil rig out there, and that's why they're delivering cargo out there.
The thing is, wind farms require a lot of maintenance, and when the maintenance crew arrives, they need to have packaged over there already to start the maintenance operation. So basically, they're delivering those packages with those drones. I think they're around 90 liters, one package, which is quite big to actually climb up with. So you cannot really climb with the person for that package up there. So you need to deliver it separately. And those wind farm operations, also you need to do inspections from time to time. So you need sometimes equipment to do that inspection as well. And that's the reason why they are delivering those packages.
Wow. Okay. So oftentimes also when we think about drones, we think they take the place of dirty, dull, and dangerous jobs. I imagine even just using a crane, you say how long it takes for these operations to normally occur. With the weather conditions over water, which both of you probably know a lot about, given the aircraft that you're designing, you know, the safety features of this have to be pretty robust, I would think, to be able to fly over the water and then drop. Yeah, Anurag, please.
The kind of conditions we are designing for are very, very tame and benign compared to these rigs. They'll be in very deep waters, and it'll be very, very choppy and turbulent there. We are talking of Maldives, which is like very shallow, very serene most of the time. So that they're completely different environments.
Yeah, I don't know a ton about weather. What I know about weather is from what I studied for the Part 107 drone test, which I memorized answers, let's be honest. And also, you know, from my buddy Don Bershoff from True Weather Solutions, actually one of our sponsors. He's just like this weather acolyte, right? So I know there are unique conditions over the water, especially like you said, Anurag, in the deep sea where some of these are located. So very, very cool. You know, one other thing that I think is important to highlight, because I think we often consider the safety aspects, the efficiency of this, but also the kind of the green nature of this. I don't know, Erdem, if you want to kind of elaborate a little bit on what makes this different from traditional operations to get these kind of tools or cargo out to the platforms with using a drone instead.
One of the things is, so when you want to do a crane operation or any operation with a boat, for the offshore operation, they usually use specific boats that are certified for that operation. So you cannot just bring a speedboat or a canal boat to do an offshore operation. So they are big ones, they're expensive ones. And for just one trip, I know that they are burning more than 1,000 liters of fuel. So that's one of the aspects. And the other thing is when you have another crew that is helping to do something for you. For example, when you want to do a maintenance operation, sometimes you may even need to stay over. So that's the issue. And then you need to even bring a bigger boat. So when you make things faster, then it also makes things much more cheaper with the drones, basically.
Okay, got it, got it. All right, well, really great article, and this is this is an important use case. I've heard of the wind turbine inspection use case, but to actually be delivering cargo out there to the platform is not something I've heard a lot about until you raised this article with me. So really, really cool. Erdem, do you know if other people around the world are doing this, kind of to the wind turbines?
There are other tests and trials that were going on, mainly in Europe, that were doing deliveries to wind farms and oil rigs as well. And sometimes you're just delivering a small thing to the maintenance operation because they are missing something, or there is something that they need as an extra. And those things are normally done with helicopters. So the thing is, even though it's not very regular, it's not very common to deliver those things. Even if you need to deliver one thing with one helicopter, it's very costly and even sometimes dangerous depending on the environment. So that's why I think drones make things much easier in that case. And also it's because of the industry is evolving. Like when they started the wind farms maybe 10, 15 years ago, they were probably less complicated, smaller. And now they are getting bigger, they are getting more complicated, and the maintenance operation is evolving as well.
All right. Well, very good. Well, thank you so much, Anurag. I'm going to give you this opportunity if you have any other additional thoughts or comments on Erdem's article before we move to your article.
I know that our partners Flowcopter are prototyping something like this for the North Sea installations, but they're at a very early stage, and they're using drones that don't use electricity at all. There are no batteries to charge. They're using gasoline-based drones with hydraulic transmissions.
Yeah,
But this is
got
still
it.
an early stage that not yet got commercial.
Okay. Well, good to know. We'll keep an eye out for Flowcopter and what they're doing in the North Sea. There's so many different, battery life is an issue, I think, for drones, especially for long distances. And so we're seeing, sometimes hybrid scenarios in terms of, the gasoline they're using, or even hydrogen solutions. They're seeing more and more hydrogen lately, especially for these offshore applications. If memory serves, there was another group in Amsterdam. I can see their vehicle in my mind, and I cannot remember their name, but they made a 100% hydrogen vehicle. It was a very long drone for this offshore energy type application, which I thought was really interesting. I feel like, Erdem, they're also out of the Netherlands. I don't know if you know what I'm talking about, but if not, do you know the company I'm talking about? It looks like it's very like long and tubular almost.
Yeah, I know the company. I also couldn't remember I think it was Highfly that you were mentioning.
Yeah, that's it. That's a Highfly. Yeah.
Yeah.
Yeah. Okay.
Yeah,
I met them too. That was really cool.
Yeah, and there are also a lot of hydrogen coming in because of the range. And as speeder systems, we are using the ground effect to extend range. So we are using a different approach especially for the offshore application. So you need to bring efficiency when you're using batteries. The efficiency can be from the hydrogen, or can be about how you fly, or can be about your engines. So there are a lot of different applications coming in. But I believe that the battery technology will soon catch up. So that's growing also fast. And it will be a challenge about who is doing it better, or hydrogen, hybrid, or batteries. So that would be the question maybe in 5-10 years.
Yeah, I think you're right, and we will absolutely keep track of that and keep an eye on what's working and what's speaking of working, let's move to the next article. And Anurag's article, you selected this one. Now, truth be told, everybody, I actually authored this for Anurag, and it does appear in eVTOL Insights magazine. And so, Anurag, tell us a little bit about this article and why you chose it for today.
Well, I have to apologize that I had to choose this because I couldn't find anything that was equivalent, which illustrated the point I was trying to make, which is about transporting people on the sea, the people over sea by air at a very low height. Because this is not being done, as far as I know, in any form that I have so far come across. So chose this because this was the only similar thing I could relate to.
All right, well, tell us a little bit more. So this article is about the Seahorse H5. I know when you and I talked about it when we met in Amsterdam, you're referring to it as a flying yacht, essentially, but with lots of different potential applications, at that shoreline area, everything from recreational to search and rescue and things of this nature. So tell us, first of all, Anurag, what inspired, this design, because it's really unique.
We have actually designed this for a specific place, which is Maldives. Maldives is a very tiny country. It is a country of just 500,000 people. It's a very unique geography. I don't know how many of you have been to Maldives, but it's a really unique. It's a really unique geography where the extent of Maldives from north to south is about 825 kilometers. 825 kilometers. It's not so small. And from left to right, from east to west, it's about 150 kilometers. Off this sort of a long oval, only 1% is land. 99% is sea. And it's a very, very strange geography in which going from one end to the other can take a day by boat.
Wow.
It can actually take more than a day because 800 kilometers you would travel at about 4 hours for 100 kilometers. So it'll take a day and a half to travel from one end to the other. Their capital city, Male, is where the aircrafts carrying tourists arrive. It's bang in the middle of that north to south line. And from there, the topmost tip is about 450 kilometers. The southmost tip is about 500 kilometers. And they have built resorts which are the most luxurious, beautiful resorts in the whole world and the most expensive resorts in the whole world.
This is probably why I haven't been there yet.
Yeah, they're very, very expensive, like typically starting at about $2,000 a night. That's and they're big resorts. So their simple policy is one island, one resort. So they have so many islands. There are about 175 resorts in Maldives, which are really large, super high-end resorts. And each of them occupy a complete island by themselves. So there are these atolls, which is an expanse of sea with little islands dotted all around it. And there are 26 such atolls that make up Maldives. So they are it's such a tiny country, just 500,000 people. And this country uses the largest number of seaplanes in the whole world. Their seaplane operations are by far, by a long, long margin, the largest in the world. They use some 91 seaplanes in that country. And the next largest seaplane operation in any country is in Canada, which is about 13 seaplanes. This is a staggering difference of scale.
Yeah, for sure.
And if seaplanes didn't exist, Maldives as a tourist destination wouldn't exist because that's the only way people can go to those resorts. And there are times in the day when all the seaplanes that they have are up in the air, carrying people either back or 4th, and they operate in a very narrow window because flights coming at about 9, 10, the hotels don't allow check-in till about 3, and then people have to go back and catch their flights, and flights also operate, all the international flights also operate in such hours. So the seaplanes operate in a very narrow window. They don't even operate in the whole daylight time. They operate in about half of the daylight time because of these logistics. And they require a hell of a lot of infrastructure to be built. Uh, it appears when you look at seaplanes landing and taking off that they can land and take off on normal sea, but they can't. Even if there is a 1-foot high wave, they cannot land on that wave.
Oh,
So,
really? I didn't realize that. That's interesting. I don't know a lot about seaplanes, so I'm learning here.
and all seaplanes are the same seaplanes. They are the same Havilland, Twin Otter, uh, something 600 planes. All of them are identical to each other. So all the resorts have to build large, almost a kilometer long pool of water, which is like a calm pool of water into which the seaplane lands. And in Malé, they have the largest seaport for seaplanes in the whole world. And that's a really beautiful, huge infrastructure. So when a resort is being built at that time, the place for the seaplane to come and dock is figured out. It is very, very difficult to do it in retrospect. And
So how does the Seahorse S5, tell us a little bit about it, and how is it different than these traditional seaplanes to, improve these kind of operations?
we don't intend to, let's say, compete or go head on
Replace?
against,
Yeah.
replace these seaplanes. They do their job, and they're indispensable in Maldives, absolutely indispensable. But they don't do the whole job because they can't. So resorts that are nearer to Malé get left out of the service of seaplanes. Those have to be served by boats. So there are resorts where you have to take up to 3 hours, 3.5 hours of boat rides, because for seaplanes, it's not economical to operate at very short hops. And these are somewhat larger planes. So there are 14, 15 people that each of these seaplanes carry. So they are fairly tied to the resort ecosystems. And it's a very different way that they commercially operate. They don't operate by themselves as an airline. So if you want to buy a ticket in Trans-Maldivian Airways, you can't. The seaplane service is bundled as a part of your hotel tariff. It is not separate from that. So you can't separately buy a ticket to that resort by just going to the website of Trans-Maldivian Airways. So it's a tied-in service, and it's a completely used up set of planes, and they're very expensive planes. They're each about, let's say, $4 to $5 million, and that's expensive per seat. And small hops don't happen with them because they have to have a runway on water, and then they have to have a landing on water, which takes a fair bit of space and time. So what we are doing is a very, very much smaller seaplane. Our seaplane is tiny in comparison to the current lot of seaplanes that are operating there. And ours is a VTOL, so we don't need any infrastructure at all. We just straight away land and take off from the beach of any resort. But we need a lot of range. We cannot operate a plane like this with the normal requirements of normal range of what eVTOLs would do. I'm sure ground effect could do it, and that would be an interesting thing to explore for somebody else. But this makes it possible to go on a very short hop also. So there are a lot of resorts within 5 kilometers of Malé, where people just get stuck there. And we have experienced that many, many times. Sometimes you want to come back from the resort, but you don't have an available boat for the next 3 hours or 4 hours. Or if it is available, it is fully booked. You are willing to pay, but you don't have an option at all. There is no service available. But all that apart, the most important thing that we are working on initially is addressing the issue of emergency evacuation of people who fall sick in these resorts. These resorts have very wealthy people. There are sometimes very old people as well. And if somebody has a heart problem and needs an immediate evacuation, there is nothing. It could, the only thing to.
That's, I was just going to say that is super frightening, because when you're talking about 3 hours by boat to get from one place to another, like you said, in this kind of an emergency situation, that's no joke. I mean, minutes can mean the difference between life and death.
No, this can be 20 hours. From
20 hours.
Really, it can be 20 hours by boat to the nearest hospital. This is,
wow.
That doesn't work. So we are positioning a service that will have an air ambulance in the form of the little thing, which will be able to wheel in a stretcher and can carry a doctor and a nurse in addition to the pilot and the patient to a nearby hospital. And we intend to provide this as a 24/7 service with the pilots stationed in the hospital, and the hospital will co-locate that air ambulance, and it will be linked to the government's ambulance calling system. This is
that is so important. Yeah, I was going to say, I'd love to hear Erdem's thoughts on this. This what did you call it? Micro seaplane concept, because this is the first time I think anybody's really kind of proposed this. Go ahead, Erdem. I'd love to hear your thoughts.
And we also need to go on land. If we land at the edge of the sea, we have decided to make something that only flies 30 feet above water.
Gotcha.
And,
okay.
The reason is that we don't want to get into certification issues where we are flying at 2,000 feet. Therefore, all security concerns of a normal aircraft become our concerns also. So we want to position our vehicle as not as a plane. So we don't call it although we call it a micro seaplane, and we are very careful when we are talking to the government that this is not a plane. This is the security aspects here are more like those of boats and cars. So from a 30 feet height, even if we just fall without anything that could help us, if we just fall from the sky, we would hit a terminal velocity of about 60 kilometers an hour when we hit water. And that is something that can be addressed by airbags and some other things. It does not need, whereas any aircraft falling from the sky from the regular flying height, nobody will survive. But here, we don't expect anybody will die. We will have airbags, which don't happen in airplanes. Each seat has an airbag. Here, the entire plane has flotation bags, which would deploy when it is hitting the water.
Very cool. So I'm gonna pull it over to Erdem to get his thoughts on this as well.
This is also something we believe in, Don. So the maritime air mobility, I think, also Anurag. So from the drone background, so in Europe, they regulate drones with something called SORA, right? So that's the specific operational risk assessment. And according to SORA, your ground risk is based on where you're flying, basically. And when you're flying over the water, there are so many drone corridors now established in the Netherlands, in the UK, in Scotland, where all the drone flying is happening over the water, because that is creating less risk for the third parties, basically. And that's making your operation overall less risky. And we also believe as Speeder Systems that that's the way to go for the mobility side of things. And if you look at that, like 40% of human population lives within 100 kilometers of a coastline, which makes things very interesting for the mobility sector. And these are mostly the fastest growing cities. When you have those cities growing so fast, then that's what you would like to be there. The other thing is
we've got a little doggy in the background somewhere. I'm not sure.
That's me. Sorry, there is one dog somewhere.
It's so funny. It's almost like every time you talk, your dog barks, and it's like hilarious. But go ahead, keep going.
Yeah. The other thing is when you're talking about maritime mobility, as Anurag explained, the infrastructure requirement is less. So if you have something that can land water anywhere, all these 40% population, you can serve them easily. And then you don't need those drone ports, vertiports, all these different infrastructures, which is, again, what we believe in. My question is about those seaplanes, because this is a very niche operation, right? So you have A to B, which is predefined, and they have been doing this operation on a regular basis, and all the resorts are actually being built around that, reach, right? So how do you want to disrupt that commercial understanding? And all the operators are all about, okay, we have been doing this for 100 years like this, why do we want to change that? That's the normal operational mind, right? So
So
how
we
do you
don't
want
want
to
to.
disrupt the operational mind? That's what I would like to ask.
We don't want to disrupt it in the first place. We don't want to have anything to do with it. We leave it completely untouched. The operations that are currently done by the seaplanes will continue to be done in the same way. We cannot compete with that. So seaplanes go at about 3 times the speed that we go at. If we go from Malé to a resort that is 500 kilometers away, we would take about 2.5 times the time that the current seaplanes will take. It's not practical for us to do that, and we don't want to do that. We are handling it in only 2 ways in Maldives. One, we will deploy these air ambulances, of which there is a really special need there because of the unique geography. This is not the same as being in Europe and falling sick, or in being in India, or a place where some kind of a reasonably fast transport is available to a reasonably nearby hospital. Here, the hospital is far, and the transport mechanism is going to go at some 18-20 kilometers per hour at best, and that too may not be available. You need much faster ability to evacuate patients. So that's what we are creating. We will station one air ambulance. That means 26 air ambulances, one in each atoll of Maldives. So we would try to provide a service level of about 20 minutes. We should more than a 20-minute call away from anywhere for an emergency call. And the second thing we will be doing is installing this drone in every single resort. So we will install these drones in 175 resorts. They will be stationed there. They'll be parked there. There'll be 3 shifts of pilots who will live in those resorts. There will be a engineer who will live in those resorts. So these are available 24/7 by 365 to the resort. They may or may not need it 24/7, but they're available at all times. So they also pitch in as an air ambulance, but they're not fitted like an air ambulance. We are not fitting each drone with an advanced life support system, etc., which the air ambulances would be fitted. These are fitted with seats for 5 passengers. We can remove one seat in an emergency quickly and wheel in a stretcher. But these would be used for short joyrides for tourists who come to the resorts. Maldives resorts are quite different from many other resorts in many other parts of the world because they're destinations. They're entirely destinations that people go to. You don't go anywhere else if you go to a resort. You stay there for 3 days or 4 days, and then you go home. So each resort has all the water sport facilities. Also, each of the 175 resorts, its own snorkeling, has its own diving, parasailing, because you don't take the passenger to any other central place to do this. Each resort does it on its own.
Wow,
So
this is so I want to make sure that we're kind of staying on track. I know we're having issues with our other 2 guests right now. I don't expect Dr. Moro to meet us at all. She's literally at sea with 0 connectivity. Unfortunately, Sean is having, although he's in, I believe, the Washington, D.C. area in the United States, connections issues trying to get onto Skype. So super exciting what you're doing, Anurag. Thank you for sharing this and your vision. of bringing air ambulances and short kind of offshore hops to the Maldives with the Seahorse H5. And of course, Erdem's article was super cool also about the use of drones and as cargo delivery to offshore wind farms. I want to take a second and once again thank our sponsors today. They are Airspace Link, True Weather Solutions, Clarify Consulting, and UAS Strategic. Those latter two will be sponsoring our Full Crew Live next week from Las Vegas and the Commercial UAV Expo. So check out that stream next Thursday. And then True Weather Solutions is going to be joining us, by the way, with Anurag and Seahorse Air at IAM Madrid at the end of September. So really excited to see Anurag again in person, this time in Spain. So let's go ahead and pop up that next article. Now, this is one that Dr. Jessica Moro had submitted. And, you know, when you think about maritime vehicles, I think this is kind of what more traditionally you might think about in terms of autonomous vehicles. And this particular article is titled Innovative Surveillance and Autonomous Systems. And it really focuses on uncrewed surface vehicles, or USVs, and autonomous surface vehicles, or ASVs. I mean, in the maritime environment afloat, there and also beneath the surface, there's so many acronyms we can talk about. MASS, right? The maritime autonomous surface ships are the really big ones. You've got your ROVs, your remotely operated vehicles that are like on basically a tether that operate underwater. Just so many different maritime uncrewed vehicles, if you will, that are out there. But this article focuses on the surface, the uncrewed and autonomous surface vehicles. If you've never seen one of these things, they come in a lot of different sizes, and many of them carry sensors with advanced tools, and for the military, sometimes equipped with effectors or weapon systems. The interesting things about these is they can operate in hazardous areas, of course. Again, we talked about the 3Ds in the air. There's also 3Ds, right, in the water and on the water and underwater. There's areas of poor visibility, of course. You can imagine underwater conditions made worse at nighttime. And, you know, so what are some of the different market sectors, if you will, besides defense, or some of the market use cases? Inspections, you know, those wind farms that Erdem was talking about, they go deep underwater. And when you think about inspections, it's not just above the surface and in the air that you have to inspect the blades or the rotors up there. You have to inspect the base of those things underwater as well. So this is really, when you think about those inspections, they're really multi-domain. And these surface vehicles can maybe get more to the surface. Now, the United States Navy has been using two different prototypes. Of course, you got to love the names. They're always cool. We got the Sea Hunter and the Sea Hawk. And these are the ones they're using with cyber warfare capabilities to disrupt radio signals. We've seen, well, in the Black Sea, right, in the Russian-Ukraine conflict, lots of cyber warfare happening, or EW, electronic warfare. And we've also seen autonomous surface ships being used, very tiny ones, being used to destroy entire very large ships of the Russian Navy. So these vehicles are really interesting. They are not as costly, obviously, as very big ships. They can be attritable, they're lightweight, and you know, the Navy, U.S. Navy is looking at large ones as well, with longer endurance capabilities. But you can see where these could really change not only the face of warfare, but operations like what Erdem was talking about from with respect to the wind farms. You know, I've also heard or I saw a video where this company had made an autonomous surface vehicle for search and rescue, where there's no person on board, and then they have this like a ramp that comes down, if you will, off the back of it. It will go out to a drowning person. Theoretically, that person would be able to grab onto that ramp and, assuming they're in good enough condition, kind of climb onto the boat. But I'd love to hear your thoughts about this, because I think these uncrewed surface vessels, these autonomous surface vessels, there's so many things that they could be used for, both on the military and commercial side. And, I'll go to Erdem first, just because in the Netherlands, you've got so much water there. Are you seeing some of this, some of these vehicles, being used? And if so, like, what use cases are you seeing?
I have seen actually a lot of use cases around the security, port security, infrastructure security. So there are a lot of USVs patrolling the wind farms as well, the petrol lines, actually the pipelines. There are a lot of pipelines that need to be secured these days. And the port security, Port of Rotterdam actually has a project around that for the port security. So they are using a combination of USVs, UAVs, and ground-based systems, radars for the port security application. So when you think about the port, you just think about maybe a 1 or 2 mile space. But in the case of Rotterdam, it's actually a 40-mile space inland. So even if you want to go from one side of the port to the other side over the land, it takes half an hour or something. It's a huge area that we are talking about. And there are ports that size in Europe and in the US and in Asia as well. And that is a lot of that has big potential using USVs, and actually again a combination of USVs, ROVs. ROVs are the remotely operated vehicles. Those are the mini submarines. And even for our use case, we are even launching smaller drones, smaller submarines. That combination helps you with the operational spectrum. Basically, you can do a lot of different things. And from the USV, I have also seen the military applications. I think it was Korea that they were designing an unmanned vessel that can launch drones. Like it's a aircraft carrier, but a drone version. Think about that.
All right. Yeah, go ahead, Anurag. Please jump in.
Yeah, I was just wondering what would be the real effectiveness of a vehicle of any kind, unmanned or manned, if it is navigating its way on water, because the speed would be very low. And it would be far more effective to have an aerial vehicle instead of something on water. Like the speed would be 6 times, and you could go a little higher and you could survey so much more. Because it is unmanned, the risks to humans is not there anyway. So I have not understood the benefit of putting a surveillance vehicle which is unmanned on water.
I'd love to hear Erdem's thoughts on that, if you have any thoughts on it. I mean,
I think that's a size versus endurance issue. Like if you have a surface vessel, you can go out for weeks and not refuel, right? But if you have a drone or something that is flying, you have to come back, even if it's big. I think the highest number that I heard is like 30-35 hours. So that's the maximum size, and that will be very costly if you make something that size and with that endurance. In a surface vessel, you can just stop and stay, or just anchor somewhere and see something, what's happening, and then deploy something when it's needed. Again, that's the combination idea, right? So if you want to have a combination of different assets, then that gives you different dimensions to the operation. I think that's the thing.
Yeah, and I think in terms of the actual mission, like Erdem's talking about security missions in particular, to be able to do that with a smaller vessel without a person on board, just think about in terms of the United States Navy, like why would they care? Why are they investing in this technology? Well, they don't have to put a sailor on board a larger vessel to do a similar mission. Like you can get so much more accomplished and not have to put people at risk, or just, that's a sailor that can be used for another important task, instead of sitting on some vessel, like floating around somewhere looking for things. So I think that's just one example. But when we think about what the military, and I think what more writ large people are calling UXS, right? Uncrewed systems, whether they're air, whether they're land, whether they're by sea, whether they're undersea. A lot of those benefits are the same in terms of, expense, in terms of efficiency, and as we talked about earlier, the 3Ds, doing those dull, dirty, dangerous type jobs that, why have people to do those when you can have a robot, kind of patrolling the area. But I mean, I think the security application is just one of so many. And I really appreciate Dr. Moro giving us this article. It's unfortunate we can't get her here, but ironically, she's a human aboard a ship doing a mission and can't dial in. So anyway, I don't know if either one of you have any other closing thoughts on this particular technology or this article before we kind of wrap it up. So, all right. So here's what I'm going to do. I'm going to give a hat tip to Sean Pribyl. Sean is a partner at the law firm of Holland and Knight, and Sean and his firm have been involved in my Law Tech Connect workshop every year for the last couple of years at AUVSI Exponential. Sean picked a really cool article. I don't really want to get to it because really it's very legal focused. It was about Coast Guard autonomous ships and the efforts to regulate them. But here's what I'll tell everybody. If you go on my website, P3 Tech Consulting, under Law Tech Connect, in 2023, Sean was on my Maritime panel, and you can access that panel and watch that discussion about these USVs and ASVs and all the interesting legal issues that arise when you're making something autonomous, when all the regulations, just like we're seeing in the air, for the sea were made for having humans aboard the ship or aboard the boat. Things like you wouldn't think about necessarily, like having a watch person, like that's required in some respects. And then there's this idea of, a duty to save people. If you're afloat and you see somebody overboard, you have a duty to save them. How do you do that if you're on an autonomous surface vehicle, unless you've got that built into your model, right? So some of these Navy ones probably don't have that, is my guess. So again, really weird legal issues that arise, and it's very unfortunate. I know Sean has literally been in the background for the past 50 minutes trying to log in, and we're sorry that he couldn't do that, but we appreciate him. And again, check out his participation in our Law Tech Connect workshop. And last year we had another maritime panel that involved Commander Tracy Reynolds from the United States Navy, who talked about what the Navy is doing. So really cool stuff. But this is all she wrote, I think, for today. We got to hear about offshore wind farms and that kind of drone maritime application. We got to hear about Seahorse Air's H5 and this really interesting Maldives application, near the shorelines. And it's been great having you both. Really appreciate you coming from around the world. It's crazy that we were able to get you and not the guy from Washington, D.C., of course. But once again, real quick, want to thank our sponsors, Airspace Link, True Weather Solutions, Clarify Consulting, and UAS Strategic. And for everybody out there that watched, thank you so much. And for Mike in the background that's been working with Sean and also keeping this going the whole time, we appreciate you as always. Looking forward to seeing you again. So Anurag, we'll see you at IAM Madrid here shortly in September. Erdem, let me ask you before we sign off, is there an event coming up that we might see speeder systems? Are you going to be in Madrid? And if not, am I going to see maybe some of your teammates at CES in January in Las Vegas again?
In September, actually, in the Commercial UAV Expo, we have our partner company TTP, and our speeder model will be there as well. So you will see some of our colleagues there. And we will be also in Amsterdam World Aviation Festival, which is in October.
Okay, awesome. Well, great. I'm excited to meet some of your colleagues. Send me an email and an introduction. I would love to set time and meet them.
I will, Don. Thanks a lot.
That would be great. All right. Thank you, everybody. We are out here.